Hello young friends, this video is being brought to you by Rao Scientific Society. So the series of videos which we are going to show you will help you to understand the fundamental scientific principles which you see around you, and it will help you to develop friendship with science. What I have here is called a roller coaster. I am sure you have seen such roller coasters on a much larger scale in the amusement parks, right? So you would have had a lot of fun going on a roller coaster. Now what I am going to do is to place this small spherical ball at this point and then give it a push so that it is going to come down and then hopefully go through all of this roller coaster and end up over here. So let's see whether that happens. Okay, now observe carefully what happens. I placed it here in the slot and then give it a small push so that it's released from that slot and then it falls down and it goes through. So what is happening here? Now again, when I place this ball over here, it is having a potential energy. So let me say that this is my reference level. So with respect to this level, so whatever is this height, so mass of this ball times the acceleration due to gravity multiplied by the height will be the potential energy of this object. Now when it comes down, basically it's being accelerated by gravity, it goes down, and at the lowest point its kinetic energy will be maximum. But after that it goes up again. So what is going to happen is part of its kinetic energy is getting converted back into potential energy. And then again it goes down. So you see that there is a back and forth transfer of energy from the form of potential energy to kinetic energy. So that's what is happening here. Now, of course, energy may not be again perfectly conserved in this case. Why? There will be some losses again due to friction, right? So that is always to be expected. But assume that energy is perfectly conserved, then suppose I place it, this ball, instead of at this slot, suppose I place it right here in line with the topmost point. Will it go through? Now according to energy conservation, it should go through, because whatever is the potential energy here, if it reaches here, it will get back its same potential energy. So it has sufficient energy, in terms of energy, it has sufficient energy to reach this point. Then once it reaches this point, it should go through. Now let's see what happens if I do that. It did not go through. In fact, it fell much before reaching that point. Of course, part of the answer is that some energy is lost due to friction. But even otherwise, even if things are perfect and no energy is lost to friction, it cannot go through, because it requires a minimum velocity to go through this point. Why is that? Now notice that this is almost circular. So we know that any object moving through a circular path experiences a force towards the central point, and normally we call that resultant as a centripetal force. Of course, here the centripetal force is provided by gravity as well as the normal reaction exerted by here, this frame on the ball. Okay, so you can show that, now this is left as an exercise to you, you can show that a certain minimum velocity is required for it to go through this point. That velocity cannot be zero. So that is why if I place it from here, it goes through, but if I place it at the same height, it does not go through. Okay, so I am not giving you detailed calculations of this, but you should be able to do that by writing down equations which describe the conversion of potential energy to kinetic energy. Now let's see it once again. I place it back in the slot and then it goes through. But when I placed it here at the same level, it did not go through. Now think about that, and I think you will have the answer to that. Thank you.